This chapter is all about quadratic formula. And in order to solve the quadratic formula, which we will learn in a few days, we need to learn how to simplify radicals using factor trees first. Most of the time, you will have an exact answer, which means no decimals are allowed. So the first three problems on your page are perfect squares. And what a perfect square is it's the same number multiplied by itself to give you the number inside the square root. So if you think, what number multiplied by itself will give you 25? If you said 5, you are correct. 5 times 5 is 25. So since we have a pair, our answer is just 5. So what number multiplied by itself will give you 100? If you said 10, you're correct. Because we have a pair of 10s, 10 is just our answer. We have no numbers left over. What number multiplied by itself will give you 9? If you said 3, 3 times 3 is 9. That's correct, so our answer is 3. These numbers are called perfect squares. Remember, there is no square root over the number after we evaluate. So if you noticed, every time we broke things down and took out the 5 or the 10 or the 3, this square root symbol disappeared because we had nothing left over inside the inside the square root. So 5, 10, and 3 would be your answers. When we simplify using factor trees, not all numbers are these perfect squares. In fact, most aren't. What I would suggest is you should know your perfect squares up to 12. Know your perfect squares up to 12. Because if you don't, then we have to use a factor tree to help us simplify a radical to give us an exact answer. An exact answer means there are no decimals. Okay, so what we're going to do is we are going to break down the number inside the square root, this 12. Okay, so we have to come up with factors of 12, which means what multiplies to the number 12. There are multiple answers to this. There's 6 and 2, there's 3 and 4. Either one is correct. 6 times 2 is 12. 3 times 4 is 12. So we're going to use 6 and 2. We want to break this down to the prime factorization, which means there's nothing else that multiplies to a number besides 1 and itself, and 2 is an example. Nothing else multiplies to 2 besides the number 2 and 1. But 6 we can break down. 6 can be broken down to 3 and 2. Once you break down a number, it's gone. It's being represented in different numbers. So to figure out our answer, if you think of what we did before, we had pairs. We took out this because it's a pair. We took this out because it's a pair. We have to come up with pairs in this answer. So we have a 3, a 2, and a 2. We have a pair of 2's, so that's what comes outside. Our pairs come outside. Our numbers with no pair stay inside. So since this 3 doesn't have a pair, it stays inside the square root symbol. If you take out more than one value, you multiply it together. If you have more than one number left over, you multiply them back together. So since this is just one number each inside and out, 2 root 3 is the exact answer to simplify square root 12. So let's do a few more. What numbers multiply to 48? We can say 4 and 12. And then 4 can be simplified to 2 and 2, right? 2 times 2 is 4. Because we broke that down, we can cross it off. 12 can be broken down again to 6 and 2. 12 can be erased. And 6 can be broken down to 3 and 2. 6 can be crossed off. So now we have 4 2's and a 3. So we have a pair of 2's here, a pair of 2's here. So that means we circled 2 pairs of 2. So 2 number 2's come out. And we just have this lone 3 left over, so he again stays inside. So the square root of 48 can be simplified, remember we multiply, to 4 square root 3. 72 can be simplified to 8 and 9. 8 can be simplified to 4 and 2. 9 can be simplified to 3 and 3. We're not done simplifying because 4 can be simplified again. We can take out 1 pair of 2's, 1 pair of 3's, so that's what comes outside. So when you circle the pair, you could take it out. When you don't circle it, it stays inside. So the only number that's not crossed off or circled is the number 2. So this answer would be 6 root 2. 20 can be simplified to 5 and 4. 4 can be simplified to 2 and 2. We have 1 pair of 2's that comes outside the square root symbol, and the 5 is the only thing left over, so it just stays inside. 125 can be simplified to 5 and 25. 25 can be simplified to 5 and 5. We have 1 pair of 5's that come out of the square root, and this 5 that stays alone inside. Now, if you have a negative inside the square root, you cannot do this. If you put it into your calculator, it's going to say error. So this is a no solution. When a negative is on the inside of your square root, it is no solution. For number 21, or number 6, square root of 21, that's 7 and 3. 7 cannot be broken down. There's no other numbers that multiply to it, nor 3. So since we cannot take anything out, your answer is just square root 21. Okay, but make sure you show me the work to prove that it still stays. Sometimes you're going to have a number out front. So we have to figure out what's going to multiply to 336. So 336 is divisible by 3. So what we're going to do is we're going to ignore this 2 right now. We can't forget about it, but we're going to simplify just as we always did. So we have 3 and 112. 112 can be simplified by 2, and you're going to get 56. 56 is multiplied to 7 and 8. And 8 can be simplified to 4 and 2. And 4 can be simplified to 2 and 2. So what can we take out? We can take out a 2. We can take out another pair of 2's. And this 3 and 7 are alone, so they stay inside. Notice I'm drawing my multiplication symbol. The one thing we cannot forget now that we have this number out front is that it's saying whatever this is, you have to multiply by 2. So I'm going to bring that one down. So now we have to do 2 times 2 times 2, which is 8. Square root, if we simplify 3 times 7, that gives you 21. So the answer is 8 square root 21. So remember, we're always going to take the number outside and bring it down into our answer. So whatever we get, we multiply it by that number out front. So 28 is divided by 2. When divided by 2 is 14. 14 can be broken down to 7 and 2. So we have one pair of 2's that can come out, and our 7 stays inside. And we have to simplify what's out front, so 8 times 2 is 16, square root 7. Now, in the problems before, we had a negative on the inside of our square root. You cannot have that. But a negative on the outside is totally fine. So we're going to bring down this negative 6 and simplify the square root of 300, which is 3 and 100. 100 can be broken down to 10 and 10, and each of these can be broken down to 5 and 2. So we have a pair of 2's that comes out and joins the negative 6, and a pair of 5's that come out and join those. What stays inside is this 3 that's not circled or crossed off. So we have to ask ourselves, what's 6 times 2 times 5? Negative 60 root 3. Try your in-class practice. Make sure you have your teacher check it. And then take your quiz, which is online. Good luck!